Hey, Wiz. So DSPy, when we use it for prompt engineering versus when we use it for RAG, is it the same thing or is it like way different?
It's basically the same thing, Greg.
Huh. Basically the same thing. What about if we try to build a RAG system with a tool like LangChain and then put DSPy on? Does that add some complexity?
It sure does. Yes, absolutely.
Okay. So we can optimize prompts or we can optimize prompts within RAG. But based on the way we build RAG, optimizing those prompts might be a little more complicated in some cases.
That's
Something
correct.
like
That's
that.
absolutely right.
This sounds like a lot to untangle today, man. I think that we have some work to do to dig into the concepts before we get to the code. I think you have some banger code ready for us later, though, don't you?
Yes, we have some DSPY LangChain code to showcase what we can do with the two tools combined.
LangChain plus DSPY coming at you guys in just a while. Thanks, Wiz. We're going to dive in on the concepts to see if we can connect the things we've already learned about DSPY to the things that we need to know about DSPy. Everybody, I'm Dr. Greg. That was the Wiz. We are AI Makerspace. We're so excited to have you here today, diving deeper into one of the most not well understood tools out there, DSPy. We continue to dig deeper and learn more each time we spend some time with DSPy, and we hope you will today as well. We're focused on RAG for DSPy today. Let's get into it. All right. Is it just advanced prompting? Is it just advanced RAG? Is it just anything? DSPy, the deeper you go, becomes more and more enigmatic. Today, what we want to do is we want to chop up a few more pieces along the path to fully understanding this tool. Namely, we want to review the things we already know. We want to overlay the idea of using DSPy for prompting onto retrieval augmented generation. In other words, retrieval prompt augmented generation. And then we're actually going to combine LangChain and DSPy in a way that you won't find out of the box in their library. So stay tuned for that. DSPy. First, we'll review, then we'll talk about how we actually need to augment using this tool for a RAG system. And we're going to take some blogs from the astute and quite famous at this point, Mark Andreessen, aka P Marka on X, and see if we can take our custom data, build out the things we need, the constructs that DSPy are going to leverage while also using LangChain. Should be pretty fun, so let's buckle up and get into it. DSPy, a review. Remember that we talked about, is this just advanced prompt engineering in the last event we did? Well, today, let's sort of dig in and remind ourselves. One of the things that's often said is this is sort of a new paradigm where prompts are fading into the background as optimizable pieces of larger systems that directly learn from data. What we saw is that actually DSPy is just sort of a wrapper that we can use to automate prompt engineering. In other words, it puts the engineering in prompt engineering, right? And we'll see that this is a common thread throughout the different places that we're going to go today. We used an analogy last time, and it still holds quite well. This genius in a room mental model, when you're doing prompt engineering and when you're using your prompts, this is a nice way to sort of think about how to speak to an LLM. When we talk about DSPy, we're sort of saying, well, That's a nice sort of in-between communicator, this optimization step that we can do between our prompt and the LLM. And so we sort of add this new dimension, this optimizable step to the simple in-out prompting. If we think of an LLM as a black box that takes as input and gets an output, then what we want to do is we want to think of DSPy as sort of a step that comes in before we go to the black box. We want to think about actually sort of adding a little step right after the prompt, but before we go into a model, say, like a chat GPT. Now, of course, we're going to use developer APIs today, and we're going to use naturally just came out 4.0 mini. Whatever you use, though, staying in the closed source domain, it's helpful to think about this optimizable step as sort of the control knobs on the input that will allow us to change the output response. So this is quite helpful. The easy way to think about this is as you're doing your prompts and you're doing LLM application development, you might add one shot, two shot, few shot examples to your prompt. In many cases, this is exactly the kind of thing that DSPy is doing. So in other words, DSPy allows us to tweak the input to get a better output. And realistically, if we're using an API, we don't just provide the input, but we provide different types of roles to our input API call, the system, user, and assistant roles into that step. Now, for doing one shot, two shot, few shot, we're going to use the user and assistant roles. We can also change the instruction level prompt. This is something that DSPy gives us access to, but often isn't necessarily the best way to go about optimizing your responses and thus your system's performance. We can sort of overlay this analogy of the genius in a room on this to kind of get a feel and a visualization of how to think about prompting using DSPy and talking to the black box LLM. So let's think about advanced RAG now. But let's focus on some language that's been used to talk about DSPy in the past by the creator. Scalable, explainable, and adaptive NLP with retrieval. Seeing this keyword, let's follow the retrieval. Context, let's say. Unify retrieval-based NLP with in-context learning. This is particularly interesting because, as many of you who follow our content know, we often talk about retrieval augmented generation as the sum of two parts, dense vector retrieval and in-context learning. We can see that visualized directly here. We'll see this diagram more and walk through it more slowly in just a little while. But sticking with this idea of retrieval, in the original paper from December 2022, the Demonstrate Search Predict paper, DSP, in its initial form, talked about fully realizing the potential of frozen LMs, language models, and RMs, retrieval models. Let's overlay this idea of an LM and an RM onto our RAG system. So here we can see that the LM is simply the chat model and the RM is simply the embedding model. This is what was meant by the authors in the original paper. So these retrieval ideas and vocabulary are important to keep track of. Of course, the LMs, we've briefly discussed it already. Rather than text in, text out like ChatGPT, we're going to use an API chat style that uses a list of chat messages in and chat message out. System, user, assistant roles are all in play here. LMs, check. What about RMs? Well, let's recall the RAG process. First, why RAG? Because we want to avoid hallucinations. We want to avoid lying by the LLM. We want to fact check the LLM with reference material by adding that reference material to the prompt and thus getting better answers. So we like to break it down here at AI Makerspace into dense vector retrieval and in-context learning. That is, when we ask a question, we begin the retrieval process. So we go to the embedding model, aka the retrieval model, and we convert that question by tokenizing it, by giving it a vector representation, and going and searching into the vector store for similar vector representations in our data that's already been chunked and tokenized and vectorized. We set up a prompt template. It reads something like, use the context to answer the user's query. Say, I don't know, if you don't have any context. And make sure that you have good context, please. We return the reference materials from the vector store similarity search, and that process is called dense vector retrieval. Of course, you can do interesting things here, sparse dense, et cetera, et cetera. There's lots of stuff you can do with retrieval. That's not really the point of today's talk, though. In-context learning is the next step. We're simply putting all of our reference material into the context window. That's all. This RAG process is not yet complete because we haven't done our generation and gotten our better answer, presumably. So this piece that we focus on first is called the retriever, especially in a LangChain context. Dot as retriever is something that you guys that are building with LangChain are all too familiar with. But importantly, we want to distinguish the retriever from the retrieval process and from the retrieval model in a DSPy context. The RM is the retrieval model, is also the embedding model here. And we want to keep that straight in our minds. Now, with this in mind, we can take a look at some of the other language that's been used in the papers as the DSPy framework and toolset has evolved. In January 2023, they said, it's all about exchanging text between an LM and an RM. Okay, yeah. Yeah, okay. I can kind of get with that. In August 2023, they said, well, actually, let's say like we're at this next level where we're actually trying to unify all of the patterns of generative AI. Prompt engineering, fine-tuning, agentic reasoning, and retrieval augmentation. We want to sort of create this framework that does it all. And today we're only focused on the retrieval augmented generation. There is additional complexity that, of course, we could go into with enough time. But today we're focused on RAG. But even within RAG, we have prompting. And as we go and we try to optimize what's in the prompt, as we add one shot, two shot, few shot into our prompts, we're effectively doing a fine tuning. And so this automation of the prompt engineering is an automation of the fine tuning. We see that it's all really about stacking into pipelines your systems. And really, it's about leveraging, in most cases, it's about focusing on optimizing the prompts wherever they fit into that stack and that pipeline. And we'll visualize this today. It's to get away from hard-coded prompt templates. Fundamentally, this is seen as a big, big problem by the creators of DSPy. And perhaps it is a big problem for the industry. Ultimately, this allows us to work at another layer of abstraction and allows us to be a little bit more declarative. And that's where sort of we go from demonstrate, search, predict to kind of the way we're talking about DSPY today, declarative, self-improving language programs, Pythonically. Okay. So let's talk about how we can augment DSPy for RAG. We can do this very similarly to the way we can think about doing it for prompt engineering. Remember, RAG is just another generative AI pattern. It's not like a specific thing. We can leverage it. There's retrieval and there's prompt augmentation and there's generation. We're sort of combining things. But we can also take RAG and kind of squish it down into one thing that can be easily visualized. Let's do that. Let's get RAG so that we can think of it now not as a complex RAG system, but as a black box. This is going to allow us to do exactly the same thing that we did when we talked about prompting an LLM. That is, we can think of DSPy as a precursor. We can go ahead and get situated with this optimizable step, these control knobs. We can think about DSPy as allowing us to tweak the input to get a better output. But let's zoom in, because that's not perfect in terms of a visualization, in my opinion. Let's zoom in on what the input is that we're actually changing. If we zoom in to the diagram that we saw earlier with dense vector retrieval and in-context learning, with the retrieval model and the language model, we can see that these control knobs and our input are actually happening in context. They're actually happening betwixt and between the RM and the LM, which is precisely what we heard in some of the initial language from the Demonstrate, Search, Predict paper. Okay. I want to offer an analogy to everyone on why this is potentially useful. One of the tools out there that you may have heard of to assess and improve RAG systems and applications is called RAG assessment. Now, RAG assessment, or RAGIS, is something that we can take our basic RAG system and we can sort of look at the output so that we can optimize the input, right? You have to have an output and you have to have an input to optimize any system. But there are many different components of a RAG system. When we build a RAG system with LangChain, we have document loaders and text splitters and vector stores and retrievers and the prompt. We can actually use RAGIS to decide, well, should I replace any of these? Should I swap these out? Should I use some advanced retrieval techniques, different chunking? And so we can sort of look at each of these pieces component-wise to figure out, okay, how should I change my system to improve it? And we can also look at the models themselves, the embedding model, the RM and DSPy context, or the chat model, the LM. And of course, we can swap these out as well, or do fine-tuning. So the idea here, that's often the right way to think about RAGIS, is that we can improve retrieval to improve generation. As we've often said, in our courses, as goes retrieval, so goes generation. And we've seen it in our consulting work as well. Retrieval is quite important to do generations well. This is what's called metrics-driven development. We need to establish a baseline, some output number that thus is optimizable, and then we can change stuff that will potentially improve that metric. Then we recalculate, we see if we improve. So with DSPy, what we want to think about is, rather than focusing on retrieval, as we often do in Ragus, we want to focus on augmentation. We want to focus on augmenting the context to improve generation. This is the key here. What are we talking about? We're talking about focusing on this now being the input, this now being the thing that we're changing, this now being the place where we're adding one shot, two shot, few shot. We're effectively doing fine tuning. We're not really focused on optimizing retrieval. We're focused on optimizing augmentation. And what is augmentation? Well, prompt augmentation is just prompt engineering, right? And I mean, we already learned that DSPy is just a wrapper that we can use to automate prompt engineering, that it puts the engineering in prompting. So, I mean, none of this is really that surprising in particular. How do we do this? Well, the construct that we saw last time that we'll continue to see, and that you'll see if you use DSPy, is called the signature. This is sort of the initial prompt. DSPy will do stuff to this thing. Think of it as sort of the seed. It will use this to sort of figure out how to tweak and turn those knobs. So let's see our example of the day. Let's learn about what we're going to build so we can kind of root this into some proper context. We're going to optimize a PMARCA QA system. We're going to take the PMARCA blog archives. There's 195 pages on different categories of how to think about startups and hiring, and, you know, even into some psychology and entrepreneurship. It's got kind of a wide-ranging space that it covers. So we can ask some interesting questions. Mark Andreessen has some interesting thoughts that he's shared along the years. Now, this isn't up to date with the latest. It was packaged up a few years ago, but we're going to take it down. We're going to split it up. We're going to create a vector store from it. We're going to use a couple of OpenAI models, including 4.0 mini, 4.0 mini, that's a typo. We're going to use what we think is the industry-leading vector store, that is Quadrant. And we're going to use, for orchestration, as we mentioned, LangChain. And so if we zoom in on this, we can kind of see that the simple RAG system that we're going to use is made up of these component parts. We would be remiss, since we're doing PMARCA, to not mention the stack that we're using in an LLM app stack context. This is some great resources put out by A16Z, the venture capital firm that Mark Andreessen and Ben Horowitz run. And if we think about the emerging LLM app stack, from data preprocessing and embedding to prompt construction and retrieval to inference, what are we building exactly? We're just sort of building this. Now, DSPy kind of comes in within the prompting context, as we'll see. Let's visualize that. We have our RAG system. Let's imagine that we're using LangChain and OpenAI and Quadrant and DSPy. This is what Wiz is going to build for us to show us how we can learn about business in an optimized way with LangChain and DSPy. Wiz, take it away, man.
Yes. Okay. So the basic idea here is pretty straightforward, and it starts with It starts with me zooming in my screen, and then it starts with a bunch of super fun integrations thanks to our friends at LangChain and DSPy. Okay, so number one, we're going to set up some dependencies. Of course, OpenAI. We need OpenAI. We're going to go through LangChain, Pydantic, and DSPy AI. For right now, we do need to use a very specific version of DSPy. This is because we need to have the Pydantic feature working. In newer versions of DSPy, it's not. So for right now, just make sure that you're using the specific version. Then, of course, we're going to get all of our fun community integrations. And then, of course, we're going to get all of our fun, engines. So Quadrant Client and PDF for PyMu PDF to download that P market information. Okay, so it's going to feel very similar at the start of this, right? Because what we're going to do is we're going to talk about exactly just LangChain, right? So LCL. We're going to use our PyMu PDF loader to download those PMarca blogs. So this is the PMarca blog archive. It's literally a huge PDF filled with PMarca's blogs, right? So we have many, many pages. It's great. We're going to load that, and then we're going to go ahead and chunk it. We're going to chunk it, to about probably 1,000 chunks with 200 overlap. This is rather arbitrary, right? So the idea is if we use if we're looking to just evaluate this, right, versus how it's going to be in, say, production, we just need something to set things up. As always, the chunking strategy is going to be integral to how your application performs. One of the very powerful things about DSPy LangChain integration, in my opinion, is this idea that you don't actually need to restrict yourself in terms of what you're building in your LCEL chain. So we can do more advanced chunking strategies if we wanted to, but for example's sake, we're just going to keep it straightforward and just use our recursive character text splitter with 1,000 long chunks, 200 overlap, and then we'll split things up. And then, of course, we're going to build a vector store. We are going to need to make sure that we use a vector store or retriever. However, we don't have to limit ourselves at all, again, in LangChain. So we can use whatever strategy we're currently using for retriever, hybrid retrieval, using kind of these parent document retrieval systems, using any kind of retriever, re-ranking, what's LangChain called? Re-ranking, information, context compression, post-summarization. We do all of that, right? All we need is a component that will accept text and will return context, right? So it's going to accept our query, question, or whatever else, and then it's going to return text. That's it. When it comes to this example, we're just going to use Quadrant because Quadrant's awesome, scales very well. And we're going to, of course, use embedding, OpenAI's embeddings for text embedding 3 small. But again, you don't have to use anything in particular here. You could use a local model for this. You could use again, whatever you'd like. So it's the DSPy LangChain interaction is very flexible. We're going to set this as a retriever, and then we're going to set an LLM cache. We do this because we're going to have to send a lot of the same thing to a lot of the same models. So, caching our responses just makes things quicker, makes it a little less difficult to work with. It saves you some tokens in terms of how much you're paying OpenAI. So that's all great. Then we're going to create a simple LCL component, which you might notice is just a Python function, right? that's going to take inputs and return a list of documents in string form. We do this basically because that's what's required from the DSPy integration. That's it. Get a bunch of awesome questions in the chat. I'm just going to take a second to answer one of them in particular. LCEL is the LangChain expression language. We're about to come to the first example of that. And the idea is that it's a way to declare chains in LangChain. There you go. Okay, for chat OpenAI, we're going to use GPT-4o Mini because we can. Why not? That's it. And then we're going to set up our chain. So first of all, we're going to get our prompt content or our prompt template. You'll notice this is like a very basic prompt. We're not doing anything special here. So this is because this is what will be actually optimized by DSPy. So this is the thing that DSPy is going to help us make better, right? So we just use like a very basic prompt, and then DSPy is going to help it perform a little bit better. But it's the basic RAG prompt at the heart, right? Given context, answer the question as a tweet. Your response should contain the tweet. There you go. You can notice here is the LCL implementation, right? So we have this runnable pass-through, which is going to be chained through the pipe operator to the prompt, which will be chained through the pipe operator to the LLM, which will be chained through the pipe operator to the string output parsers. Instead of having to like add or construct this in an API, we can use LCEL in order to do this. Easy peasy. Okay, so here comes the actual integration, because all of this is just LangChain. I mean, we're familiar with it, right? It's just LangChain, or you're not familiar with it too much, but you know, the idea is this whole notebook up to this point has just been LangChain. So how does DSPy fit in? Well, it fits in through two very straightforward integrations. Number one is the LangChain Predict, which is a class that turns LangChain's language models into DSPy's prediction framework. We can see this here. I'm not going to go through the code too much, but the idea is all this is really doing is it's converting into what we would expect it to be, right? So you'll notice we have this build signature, right, with our inputs and our outputs. We have the forward method, which is expected in the DSPy module. And when we call invoke on the chain, we're going to return the forward, right? So all this is really doing is wrapping the LCEL chain into a DSPy module. Now, one of the things this is going to do is it's going to turn our modular RAG pipeline kind of into a quote-unquote black box. But that's perfectly ideal for DSPy, right? DSPy would expect this to be the case. So the integration works very, very well. We have another thing, which is a LangChain module. So that's going to wrap the actual full chain as the module. So you'll notice that predict is just going to wrap the LLM, and then the LangChain module will wrap the whole chain. The reason why this predict needs to be a DSPy object is because that is how we're going to interact with our optimizer, right? That's the thing. Remember that the optimizer used to be called a teleprompter. The teleprompter is probably the way to think about it, right, is that we're prompting at a distance, right? Spooky action at a distance kind of thing. We're prompting at a distance. So the optimizer needs to be able to interact with our predictor, which is, in this case, going to be our LLM. So that's our chat OpenAI LLM from LangChain. And then we're going to turn the whole thing into a module, as that's what's expected to continue using DSPy. But that's all this integration does, right? It just turns the LLM into a LangChain predictor, which is tightly integrated with DSPy, and then it turns that chain into a LangChain module, which is, again, in a format that DSPy expects. In order to use it, we do the same stuff that we normally do, right? When we use the chain, we just call invoke on our question, and then we get our tweet, right? So this is what we would expect to be happening, and it does happen. There you go. Okay, so now we need to generate some data. The data that we're going to generate is going to be synthetically generated because of course, why not? And also because I don't happen to have just a pile of questions and tweets concerning the PMarkup blogs. So we just whip them up with GPT-4o Mini to create our questions and GPT-4o to create our I'm very sorry, I'm just live updating the code here. Our GPT-4o to create our tweets. So we're going to use a better model to create the tweets based on the context and the questions. Easy peasy, of course, lemon squeezy. Okay, so now what are we going to do next? Once we've generated all of these, you'll notice I'm using 250 samples. You can use less samples if you wanted to take less time or hit the API less, right? Because this 250 samples means I'm going to make 250 calls to each LLM. And so that can get expensive if you use this a lot. But the idea is you can just trim this down to whatever you think is reasonable. And then we're going to create a test, train, and dev set. A train, dev, and val set. Classic machine learning, right? We want to train and validate, but then we also want to be able to test. And then during our training process, we don't show the system our dev set or our test set. We save that for evaluation. All right. Then we'll get into kind of like the fun part, I think, of the integration. So just like we would use something like LangSmith or Ragus to evaluate, with DSPy, we can also use this kind of LLM as a judge pattern where we're actually able to provide the, we're able to provide these kind of natural language questions or descriptions and then mark our generated content on that. So you notice here that we set up this assess signature, and that a signature is basically just assess the quality of a tweet along a specified dimension. Specified dimension is going to be what we tell it. And then we're going to provide some context, unless it says it's NA. We're going to provide assessed text. We're going to provide the assessment question and the assessment answer, which is going to result in a yes or a no, which will be important in a second. We're also going to use the most quote unquote powerful model that we can, for DSPy's evaluation process, which is going to be GPT-4 Turbo. Nice. And then we're going to set up our metrics. Just like with any optimization problem, we need, something to score how we're doing. And that's what this metric function does. It gives us a score. It tells us how well we're doing, right? We can't optimize if we don't have something that says if we're getting better or worse, or if our score is increasing or decreasing. And so we need to build this metric. All this does is it takes the question, the answer, and tweet, the question from our synthetic data generation, our answer from the synthetic data generation, and then our tweet is the predicted output. So that's what what our system comes up with. We're also going to go ahead and grab that context. And then we're going to say, hey, is this an engaging tweet? Is it faithful to the context? We have to include, is it dope? Because we're AI Makerspace. And then is it correct? In this case, for correct, because we're using a powerful, quote unquote, powerful LLM, we can say things like, does the assessed text communicate the same idea as the gold answer? We're going to say this because even if the tweet might literally be different, right, which is something that exact match would handle, if it's communicating the same idea, then it's going to be considered correct. So we might use different words or emojis or hashtags, but as long as the idea is the same, we're going to mark that as correct. You'll notice that we get all of these scores, and then we collate them into a list. We add up their values, and then we put this gate, right? We're only going to consider a score here if the response is correct and it's actually tweet length, right? So because tweets have a defined length, which is based on Twitter, we can give a 0 score to any tweets that are too long or are incorrect, right? And so what this helps us do is it gives us a score, and it helps really punish tweets that are wrong and that aren't even valid tweets, right? And then we return our score because we love to return our score. And then we can evaluate. And in order to evaluate, you'll notice we're passing in our dev set. And then we have some kind of, make it go faster stuff here and display the progress. And then we have this zero-shot chain. We're going to achieve a full score of 62.7, as our final score, which is not bad, right? 62.67. Okay, this is great. We can look at each of these responses and see, if it was correct or incorrect or why it was correct or incorrect. And we can see their total score, which is very nice. And then what we can do then is we can actually optimize this now. And the optimizer is this idea of using this bootstrap few shot with random search, which is a lot of words for sure, but the words mean something very simple idea, which is we're going to create few shot examples. We're going to bootstrap those examples if we have to, as in if we don't have enough data, we will synthetically create more or more accurate data, depending on how the evaluation's happening. And we're going to use random search to search through our available examples. You'll notice that we limit the number of demos or shots to a maximum of 3, and we consider 5 candidates each time we do a pass, which means we're going to try 5 different versions each time we do a pass. We're going to go ahead and run the optimizer. And what we can see is that in our optimizer run, we wind up with a score of 76.67, which is, in all consideration estimation, higher than 62.67. And this is the power of the LangChain DSPy, kind of option, right? All we need to do is provide some data, wrap this thing in the DSPy expected format with our to convert our LLM to a predictor, and then let this thing rip, and we get to a point where we're much better at actually producing responses. So and we have one quick question I'll answer on what basis is score evaluated. So the score is evaluated using LLM as a judge on the following metrics of: is it engaging, as in does the assessed text make for a self-contained engaging tweet? Is it faithful to the context? Is it dope, as in lit, cool, fire? And is it correct? And then, of course, we're also considering if it's a valid tweet. With that, though, I'm going to pass you guys back to Greg. And before I do, I'm going to remind you that we're live every Wednesday at this time. So please don't forget to like the video, subscribe, ring the bell if you want to get notified when we go live. And with that, I'll pass you guys back to Greg.
All right. Okay. So DSPy, we got the thing built with LangChain. We're seeing how we can optimize, use this phrase, bootstrapped few shot with random search. And it does sound pretty complicated. Like, are we actually just doing some fine tuning with few shot here? Is that basically what's going on?
Yes, that's exactly right. So fine tuning maybe is slightly a stretch, but I would say we are most definitely we're getting the best shots that we can from our available data in a reasonable amount of time, right? So if we have a maximum of 3 shots, what DSPy is going to do is it's going to choose or create the 3 shots that give us the best score on our training and validation data. So the idea is, insofar as we're going to call that fine tuning, it's similar in the sense that we are going to wind up with like the prompt with the 3 shots that best answer questions for us. Yeah.
Okay. Cool. So then there's another thing that we haven't discussed yet, but that I want to sort of bring into the mix just to have a few comments on. We've been using closed source models, and when we talk about using sort of few shot as fine tuning, I know it's sort of on a spectrum here. We need many, many, many shots to sort of do fine tuning. How can we think about what additional things we can do with DSPy exist if we replace, say, GPT-4o mini with, let's say, Llama 3.1? Like, are there other things that we can actually start to do within DSPy with open source models?
Actually, yes. So DSPy is not limited to just optimizing the prompts. We actually can update model weights. So we can fine tune the model, right? If we have access to the weights, then we can add this additional layer of complexity, but also benefit by fine tuning the literal generation model, right? So similar to how we would fine tune in quote unquote in real life. So all I mean by that is not with DSPy, right? DSPy is going to choose a set of examples, fine tune a model, and it's going to choose the set that pushes the model into the place that we want it to be based on the evaluation that we do. So it will optimize the quote unquote, the training set, right, to fine tune the model to perform best based on our validation metrics, which was that LLM as a judge metric function that we saw that had all of those examples. Yeah.
Yeah, which makes sense, right? Because I guess fine tuning is just looking at the input, looking at the output, bringing them closer together, optimizing to, it's like it really does fall right in line. Okay, cool. So let's just stay up here with me, Wiz. I think there's a couple conclusions we can take away, namely that, this sort of unification is really should sort of start to become clearer as you dig deeper and deeper into DSPy. And DSPy for prompting and DSPy for RAG are quite similar. They're using this sort of few shot on the spectrum towards fine-tuning approach to really dial in the prompt engineering. And in a RAG context, we call that prompt engineering, prompt augmentation. So I want to go ahead and open it up for questions from the audience here. If you do have questions, please do throw them in the Slido link in the chat or directly from this QR code. Okay, first question from Amin. Why do we use two frameworks here, LangChain and DSPy? Can't we just use DSPy to build any RAG chain we want?
Yeah, so no. Which is confusing the way I said it. But the idea is, sorry, it's a Torontoism, yes, but no. The idea is that DSPy doesn't have the full suite of integrations that we might be used to with something like LangChain. So can we build that chain in DSPy? Absolutely. We just have to program everything ourselves, right? We have to, cook up our own version of parent document retriever, our own version of the quadrant integration, create custom reward models, et cetera, right? LangChain has a handful of very useful abstractions that we can use to do these things very quickly, as well as offering the LCL benefits, parallelization, asynchronous, yada, yada. But the idea is that, while we could do it's like asking, can we do everything in Python instead of LangChain? Of course, I mean, yes, literally, right? Because that's all LangChain is. It's just written in Python. But can we do it in a reasonable amount of time in a way that fits with the rest of the ecosystem? The answer, in my impression, is no. And so using the LangChain core, we can cook up a nice chain, and then we can optimize that chain using DSPy to make it that much better.
Okay, so we actually have to use something else that's not DSPy to use our own data in a RAG application today. That's where we're at.
Well, we can use something like Milvus or Pinecone, but if you're outside of the very small list of integrations that DSPy has, you have to build your own custom RM. It is just the same as you would be used to in something like PyTorch, etc. So it's not the end of the world. It's definitely possible, but it is a longer process. It's going to take you more engineering effort to accomplish it. And if you have to change anything, your engineering team is solely responsible.
So DSPy gets funding at some point. I bet we'll see a lot more integrations, and it'll be a little bit easier to do these types of things rather than doing the custom job we did today. Okay, so then Kamakani asks, how does DSPy affect latency? Is this really adding a lot of time to our requests, or is this something you can sort of do and then launch?
So DSPy can add latency. And in fact, most of the time it will add some latency, right? So the very idea of adding additional shots means that you're going to have longer prompts, and longer prompts means more latency, right? So yes, there will likely be increased latency from DSPY. So your time to first token might be increased. What it comes down to, though, is that you control how many shots, what kinds of shots that are being added, and so you still have a very tunable knob for the amount of impact on latency. Obviously, if you put in 1,000 shots, it will probably be very good, but it will be very slow. And so we have the ability to work in that in between to get where we want for latency and performance.
At which point you would just go do some fine tuning and then kind of reset the set point.
Yeah.
Yeah. Okay. All right. So do we need a prompt template when using DSPy with LangChain, considering that DSPy handles the prompting? I'm confused by this.
DSPY doesn't handle the prompting. DSPY handles the modification of the prompt, or in DSPY native language, the signature, right? So what we saw in LangChain was a signature that DSPY can then move and change. And that's why we needed to convert our LLM call into an LLM predictor, because a predictor, if you recall from our last DSPY event, is just the combination of our LLM and the prompt, right? So the terminology is going to be confusing because everyone's trying to cook up their own terms for these things, but the prompt for LangChain is the signature for the predictor, and the signature is what will be modified during the optimization step for DSPY.
That's right. Okay, so the prompt template, or the prompt, sort of serves as this seed, the signature that from whence we can sort of bootstrap up our few shots. Yeah. Okay. Cool.
That's exactly it.
So then another from Kamakani here, getting upvoted like a legend. Thoughts on TextGrad versus DSPy? TextGrad, for those that don't know, the paper is called Advancing Robustness Evaluation in NLP by Gradient-Driven Optimization.
Yeah, I mean, I don't have thoughts that are useful, I think, here. Yes, something like TextGrad is good. When we come to these versus things, I mean, it's tough because the space is very new. What I'll say is that it's worth exploring many options right now. However, DSPy is fairly useful for these applications. So if you're already using it, it's fine. If you're already locked into TextGrad, that's fine. It's difficult to just give an answer that's like, oh, you should always use
100%.
X or Y.
Yeah. Okay. The verses, keep them coming, guys. Keep the versus questions coming. So just clicking in on this by industry thing, is DSPy something that's being used by industry right now, or are most folks kind of not at this level of optimization? They're sort of manually changing prompts and adding shots and leveraging patterns in a less automated way.
Yeah, this will be an easy question to answer 5 years from now. But for right now, what I'll say is that if you want to see people who are using DSPY in their business and industry, VoiceFlow is a very big proponent of DSPY, which is a company that builds support bots, chat bots, in addition to other things. I don't want to diminish their full suite of functionality, but that's one of the things they do, and they're very good at it. And they swear by DSPY. I think it's funny that you say. It's funny to think of it as like, DSPY is kind of it's like an advanced thing for simple systems, right? So DSPI works really well with older, less performant models to squeeze performance out of them, right? Like the better the model is, the less net impact DSPY might have, just due to the fact that the model could be great at the task out of the box, right? But we're talking about like using Roberta, using GPT-2, using Llama 2, Llama 3.0, DSPY can offer such a big benefit because it helps shore up that gap between the model's innate ability and desired ability. So it's really it's really very useful when you're not yet, yes, in Mistral, of course, Yannick, sorry. In Mistral, of course, too. But the idea is it's not really like, you're not going to see the biggest benefit. If you're using GPT-4, and you're trying to like squeeze out that extra 1%, it's going to be harder than if you're using GPT-2 and you're trying to squeeze out that extra 13%, right?
That's right. Well, and we can go back to the name on this, right? Declarative self-improving language programs, right? It's like, I imagine there's a future for these kinds of things. DSPy is just sort of, taking the name, kind of like GPT did, right? It's like, oh, we own it, but actually I think in time, and that's sort of, if I wanted to sort of learn more about your sort of 5 years from now comment, that's kind of what you're saying, right? Like people are going to automatically optimize systems, or they're not going to need to because the models are going to be so good. Like which is it in your mind?
I think it's very much both.
Yeah.
We are going to need really powerful models that don't need this amount of optimization, work out of the box, especially when we're solving things like the zero data problem, right? When you first start your company that does this thing and you have no data, boy, oh boy, is it easier to do a GPT-4 than it is to do with like an in-house Llama model, right? Just because GPT-4 is so much, quote unquote, stronger at these kinds of tasks. But once you have the data, once you have a big pile and a golden data set, right, it's going to be more cost effective to move to a smaller, more efficient model that typically doesn't perform as well, and then augment its performance up to the level of the larger model, right? So this is, I think we're gonna find ourselves where companies will start with the very, very, very powerful, expensive models, and then slowly they'll shift back to less expensive, more specialized models that they're able to cook up themselves.
Nice. Okay. Yeah. I see the future that you're painting the picture of here. So then we've got a couple more in the chat. Maybe we can do a couple rapid ones. We do have the code in the chat, you guys, if you're looking for it, and we can drop it again now. We'll also have it in the comments in the YouTube video once it goes up live. Quick rapid fire questions here. I think this one is just tangentially related, but since Udav was so active in the chat today, let's answer their question. I was using Gemini, but it took history as tokens, hitting rate limit per minute. Can I use a cache to solve that?
Yes. So no, you can use Gemini has a cache system. It's basically like you can pay for KV cache, and that will help that. But like otherwise, whenever you send the history to the LLM, because it's now going to generate a novel response, the cache isn't going to help there. But Gemini specifically, like Google does have a service where you can pay for what's essentially like KV caching, which you could use for that specifically. But otherwise, every time we send history plus a new thing, that's going to create a new output, and so we can no longer just use the cache for that, unless we have access to the hardware, in which case we can keep the history in the KV cache.
Okay. One last question. Can I use Grok with a Q LLM models? I guess that means served by Grok in the collab.
I mean, especially if you have, if you're using the LangChain integration, it's as simple as just using the Grok chat model, and that's it. Bob's your uncle. Away you go.
Oh, easy peasy lemon squeezy, baby. Okay, yeah. All right, Wiz, thanks so much, man. It's time to wrap up. And of course, we will have the slides also in the link in the YouTube. We can drop them as well here for you guys, no problemo. That brings us to the end of today's DSPy event. Now, one of the things we didn't cover, but that I'd be interested to hear if you guys would like us to cover is DSPy for agents and reasoning. This adds some additional complexity. If you're into that, definitely let us know. We love taking feedback directly from Luma or through our feedback forms. And if you're not already in the community, we'd love to have you. The AI Makerspace community is growing. We are building, shipping, and sharing all the time, including with the latest and greatest tools like DSPy. So join us. We'd love to have you on Discord, and there's a lot of great stuff going on the regular. Speaking of great stuff, the latest iteration of our flagship course, the AI Engineering Bootcamp, Cohort 4 is coming up in just about 3 weeks, just under 3 weeks, and it is going to be a banger. We have updated all of the curriculum, added 3 additional weeks, so now it's a 10-week boot camp. It includes advanced prompting through DSPy and many, many other tools. Of course, we've updated it to be up to date with the latest Llama 3.1. And check out the curriculum. You can download the detailed curriculum directly from the page that we just shared in the chat. If you're into building, shipping, and sharing production LLM applications, we've got on-prem RAG we added. We've got specific production-ready optimization techniques that we need to do to our applications that we've added. We've listened to a lot of our enterprise customers, and we really think that this is a better offering than ever before. So check it out. It's a new and improved. And finally, next week, we are going to be on YouTube Live again. If this is your first time joining us, then come check out the Mixture of Agents event. It'll be a little more researchy. And the following week, we've got synthetic data for enterprise. We're going to talk about SDG, or synthetic data generation, in great detail using the LangChain and LangSmith tooling. That's it for today, guys. Definitely provide that feedback. If you want us to do more DSPy, let us know. Otherwise, in the meantime, just keep building, shipping, and sharing like a bunch of legends, and we will do our best to do exactly the same. See you all next week on Wednesday. Bye, everyone. Have a great week.